Hello you guys and welcome back to another episode of physics. In today's episode we're going to talk about the rate of change of momentum. That sounds pretty difficult, but I promise it's not that hard. Let's just go hit that problem we're going to do today, and the problem reads something like this. Your friend Mike pulls a 5 kilogram ball at a constant speed in the x direction with a rope at an angle of 40 degrees. The friction coefficient is 0.2. Find what's tension force in the rope. Something you need to know, if you want to do problems like this, is to draw your diagram. You always need to draw your diagram to see what's going on. Here's just a simple diagram of the whole question. So we know that your friend Mike right here, Mike is pulling this ball of 5 kilograms. I don't know what's that right there. It's 5 kilograms with a rope and an x direction, right? But that's not enough. When I say write a diagram, you need to write the diagram of what's going on. Like the forces between the ball and the earth, the friction force, where it's pulling, the angle of the rope, everything. So your diagram should look something like this. So you see Mike, hey, it's like, hey Mike, what's up? Here's your friend Mike, and here's my ball. And Mike is pulling that ball at a 40 degree angle. And we know, and I know that the ball and the earth are like fighting each other. Like the ball wants to pull up while the earth is pulling down on that ball. So the ball is pulling up, and I call that N. And the earth is pulling down that ball, and that's gravity. It's 9.8 newtons per kilograms. I know that for a fact. And because there's a frictional force, what happens when you have friction? Friction slows you down, right? It's like pulls you back. So friction is pull you that way. It's like, no, you're not moving. Well, Mike is pulling that ball in an x direction straight forward. It's just pulling that way in the x direction. So the rate of change of momentum. So I know that the sum of all forces equals the rate of change of momentum. Oh my goodness. So I know that N is the ball versus earth, little f is friction, T is tension, and W is my weight. So we need to do the sum of all forces like a vector with an x and x and y coordinates. So for my x, I know that N, the ball versus earth, plus frictional force, plus the tension, plus the weight equals rate of change of momentum. And I know because N, the ball versus earth, is pulling up for the x coordinates, that will be 0. The weight is pulling down, so I know the weight will be 0. And I know because the rate of change of momentum, I know that Mike is pulling this straight forward and it's going on a constant speed. The rate of change of momentum will be 0. So having that out and this out, I know that the frictional force plus the tension force will be cosine of 40 degrees equals to 0. All this equation has to be equals to 0. Now let's do the same thing we did here for the y coordinate. Now the y coordinate is the ball versus earth, the friction, the tension, the weight, and the change of rate of momentum. I know the friction is pulling on an x direction, it's not pulling on a y direction, so this will be 0. And the rate of change is constant, so this will be 0. So I know that Ng plus Tg, ball versus earth, tension, weight, has to be equal to 0. So I know that Ng plus tension sine of 40 degrees minus mg, there's another way of writing the weight, equals to 0. Now let's regroup and time to put these two final equations together. So I know here that for this part of the equation, F plus tension equals cosine of 40 equals 0. I know that the friction force could be equals the friction coefficient times N, and this will be equals to this. See with this? It's the same thing. And for this part of the equation, for the y, I'm solving for N. So N equals mg minus t sine 40. So we put these two together, we put n with the n, like compared to equations, and we get something like this, where u mg minus t sine 40 equals t cosine 40. Right? Now, we can pull, with a little of algebra, I can pull this t out. So I skipped the algebra part, but we're going to have something like this, that t equals u sine plus cosine 40 equals a friction coefficient m and g. Now, t is what I want, because t is the tension. So I move this here, and I have t equals the friction coefficient mg divided by friction coefficient sine 40 cosine 40, and you're pretty much done. Now it's just a plug-in game where my u coefficient from the question is 0.2, the mass is 5, and the gravity is 9.8. 0.2 sine 40 plus cosine 40. If we do all the math here, we get something like this. The kilograms with kilograms will cancel. You have newtons left. You have newtons divided by this is 10.96 newtons. This is how much force, this is how much tension is in the rope while your friend Mike, your homie Mike, your brother Mike is pulling on that rope. Thank you.